Section 5.2 Binomial Distribution. These sessions we will talk about the binomial distribution. Let's look at this example. Your favorite fast food chain is giving away a coupon with every purchase of a meal. You scratch the coupon, you're gonna find out your price. 20% of the coupons entitled to get a free burger, and the rest of them say better not next time. You go to this restaurant with a group of 10 people, and everyone's order lunch. What is probability that 3 of you win a free burger? So first, you will have the coupon in here. And after you get the coupon, you will have a 20% chance to get the free burger. Or they're gonna say better not next time. So think about it. This is gonna be the complement. Either you get the free burger or you will get better not next time. If this is a 20% to get the free burger, then you will have 80% to get better not next time. Now you do have a 10 people, and then everyone's gonna order the lunch. They want to know what is the probability that 3 of you to win a free burger. So now we're gonna let x be the number of the people. Now let x be the number of people out of 10 who win a free burger. What is probability distribution of x? In these sessions, we will learn that x has a distribution called the binomial distribution. A binomial probability distributions result from a procedure that meets all of the following requirements. First requirement, procedure has a fixed number of trials. So you do have a 10 people and everyone ordered the lunch. So we do have a 10 trials. The trials must be independent because the outcome of one coupon does not affect the other one. Each trial must have all outcomes classified into 2 categories. You could refer as a success and failure. It really depends what you're looking for. Like for our example, we are looking for what is probability that 3 of you to get the free burger. So free burger, we consider this is going to be the success. And get the better not next time, that will be the failure. And our example, we only have a 2 outcome, right? Either get the free burger or better not next time. So this is the 2 categories. Last one, the probability of success remain the same in all trials. So they do have the same coupon, they do have the same percentage to get the free burger. So we call this is the probability remains in the same in all trials. I need you guys remember these 4 requirements for the binomial probability distribution. Once you confirm the example will be the binomial probability distribution, we could apply the formula to calculate the probabilities. Using the binomial probability formula, if we want to find the specific probability, we could apply the formula. This is going to be the combination. We learned it from the chapter 4, the NCX in here. And then we say the combination, we could write it out like this way. Or you guys can use the calculator to find out the NCX here. And then the x, that will be the whole number starting from 0 until the n. N, the number of trials. So in our example, we do have a 10 coupon, so n equal to 10. X, that will be the number of success among n trials. And keep in mind that x is always in between 0 to n. In our example, we want to find out 3 of you get the free burger. So the x will be equal to 3. P stands for the probability of success in any one trial. So we do have a 20% to get the free burger. So P, that will be equal to 0.20. or 0.2. Q, that's probability of failure in any one child. So we do have 80% to get better next time. So Q, that will be equal to 1 minus 0.2, which is going to be 0.8. P of x denotes the probability of getting exactly x success among the n childs. So in our example, we will have a P of 3. Example 1. Which of the following are binomial experiments? A pair rolls a pair of fair die 10 times. The number x of 7th rolled is record. First, do we have a fixed number of childs? Yes, right? Because we're going to roll the die like 10 times. So n equal to 10. Do we have two possible outcomes? Yes, we can consider this as the possible outcomes because we want to get the 7. Okay, so 7 is the roll. We consider this as success. If this is not a 7, then we consider this is going to be failure. So that will be the two outcomes. Number 3, constant probability of success. Yes, probability of rolling a 7 with 2 fair dice is constant. Last one, will it be independent childs? Yes. When we roll the die, it doesn't affect by the previous one. So each roll is independent. So we call this is gonna be the binomial experiment. B, 5 basketball players each attempt a free throw. Let x be the number of free throws made. Do you guys think this is a binomial experiment? Not really, right? Because each of the basketball player attempt a free throw, and then everyone have the different skill. So the probability of success won't be the same thing. So this is not a binomial random variable. C, in a class of 30 students, 55% are female. The instructor randomly select 4 students. The number x of female select is record. First, do we have the fixed number of childs? Yes, right? Because we try to pick like 4 students. So n equal to 4. Do we have two possible outcomes? Yes, because we try to select the female. So if females, we consider this is success. Male, there will be failure. Is the probability of success remain the same? Not really, right? Because the selection is without replacement. Okay, so the probability is not remain the same. And also, this is not an independent child. When you pick the second girl, it will be affected by the previous one. So this is not an independent. So this is not the binomial experiment. Now let's talk about the formula and how to use your calculator. If you guys want to calculate the binomial distribution probability, you could use the formula using the combination. Or you guys can use the TI-84 plus calculator directly. I just show you guys the formula, how to deal with it, but I would recommend you guys try to use the TI-84 calculator. If you guys want to find the specific probability, just like our example, if you want to find the probability that 3 of you to win the free burgers, then we are looking for P x equal to 3. Then you'll be using the binom PDF. This P talking about exactly at x. So in our example, my x, that will be equal to 3. And talking about number of childs, we do have 10 people, so n equal to 10. The P, probability of success. So we do have 20% to win the free burger. So the P, that will be 0.20. and then x, that will be equal to 3. So let me show you guys how to use your calculator. First, click on the second vase. You're gonna choose Binomial PDF. So go down. You're gonna see Binomial PDF, enter. And then the child's n will be equal to 10. P, that will be 0.20. And then the value of x equal to 3. And then click on the place, enter. So you're gonna get 0.2013. That means the probability that 3 of you to win the free burgers, that will be 0.2013. Okay, now let's try to do the example. Example 2. According to the Experian Automotive, 35% of all car-owning households have 3 or more cars. Suppose there is a random sample of 20 car-owning households. What is probability that exactly 5 households have 3 or more cars? 1 to 4 decimal space. So first, think about it. What is your n? How many number of childs? What is your p? What is your success rate? And what is your x? What you're looking for? You could find your q also. Q, that will be 1 minus p. So n represent number of childs. We do have a random sample of 20 car-owning household. So n, that will be equal to 20. And then p, the success rate. We are looking for the probability that 5 households have 3 or more cars. So 35% will be the success rate. So that will be 0.35. And then q, that will be 1 minus p, which is going to be 0.65. And then x, we are looking for exactly 5, okay? Exactly 5. So x equal to 5. We are looking for probability exactly 5. So we have the p of 5 here. I'm going to show you guys how to use the formula and also how to use the calculator. First, let's do it with the formula. We're going to plug it in here. So we do have a 20C5, the p, which is going to be 0.35 to the power of 5. And then q, that will be 0.65 to the power of 20 minus 5, which is going to be 15. Then use your calculator. We do have a 20. Go to the math. Probability, number 3. We have a 5 in here. And then we're going to times parenthesis 0.35 to the power of 5. And then we're going to times parenthesis 0.65 to the power of 15. Enter. So you're going to get 0.1272, okay, 4 decimal space. Okay, now let's try to use the calculator. Okay, plug in Binomial PDF. So click on second vase, scroll down to Binomial PDF. We do have a 20 trials, probability 0.35. X, that will be equal to 5. Go to the page, enter. So you can see we got exactly the same answer. 0.1272. I would recommend you guys using the calculator instead of using the formula. When you guys working on the test, please show me what is your x equal to, and then Binomial PDF, and what number you're gonna plug it in, and then your final answer. So for this example, we are looking for exactly 5 households have 3 or more cars. Then we could use Binomial PDF. How about if I change the questions? When I'm looking for the probability that less than 4 household or maybe more than 5 household, then we need to use another formula. So let's say I'm looking for the probability that at most 2 people to win a free burger. At most 2 people, talking about maybe no one's win a burger, or only 1 people, or maybe 2 people to win a free burger. So I'm looking for the p of x less than or equal to 2. And x less than or equal to 2, that will be including p of 0 plus p of 1 plus p of 2. If you guys using the formula, you may need to plug it in one by one. Okay, the combination times the success weight times the failure weight. Okay, so one by one. Or you guys can use the TI-84 plus calculator. Instead of using the binom PDF, we can use the binom CDF. Okay, binom CDF. The C here represent cumulative from 0 to x. So from this example, if we are looking for at most 2 people to win a free burger, so we are looking for P of 0 plus P of 1 plus P of 2. So we can use the binom CDF. Okay, binom CDF. N and P until 2. Okay, one more time. The C here, this is talking about we are looking for the probability cumulative from 0 to x. Okay, so that will be putting the 2 in here. Let's try this example. According to the Expert Automotive, 35% of all car-owning households have 3 or more cars. Suppose there is a random sample of 20 car-owning households. What is probability that less than 4 have 3 or more cars? So less than 4. So again, doing the same thing, we are looking for the n. We do have n equal to 20. Success rate 0.35. Q, the failure rate, is going to be 0.65. And we are looking for less than 4. Okay, so x strictly less than 4 here. So if I'm using the formula, I have to plug it in one by one. Okay, so you could see the first one, that would be 20z0 times the p to the power of 0 times the q, n minus the p, n minus the x, which is going to be 20. Okay, and then this is going to be your p1, p2, and p3. So plug in everything to your calculator, you're going to get this guy. Or you guys can use the TI-84 calculator. Same idea, we are looking for p x less than 4. And keep in mind, less than is strictly less than. So this is not including p of 4. And then we're going to do binom CDF, cumulative starting from 0 to the x, which is going to be your 3 here. Use your calculator. Second, vars, scroll down to binom CDF. And then we have a 20 trials, p 0.35. The x, keep in mind we're going to put in the 3 here because x is strictly less than 4. It's not including the p of 4. Enter. You're going to get 0.0444. This is the reason why I recommend you guys using the TI-84 calculator instead of using the formula. Okay, that's too much work to write it out and then put into your calculator. But one more time, when you guys working on the test, please show me all this work. Example 4. A biased coin has a probability 0.6 of coming up heads. The coin is tossed 8 times. And let x be the number of heads that comes up. Since x is the number of head, comes up head is a success. 1 to 4 decimal space. A. What is probability of getting at most 5 heads? So before that, let's write it down. What is your n, p, q, and the x? And that will be equal to 8 times, right? Because we flip the coins like 8 times. P, probability of success, the bias coin coming up heads is going to be 0.6. Q, which is going to be 1 minus 0.6. That will be 0.4. And X, think about it. What is the meaning of at most 5 heads? That will be X less than or equal to 5. Okay, so we are looking for P of X less than or equal to 5. Means we are looking for P of 0, P of 1 until P of 5. I'm not gonna use the formula because that's too much work. I'll be strictly using the TI-84 calculator. So that will be binom CDF, the N, P, and then the X. Okay, it's from P of 0 until P of 5. So there's a 5 in here. Use your calculator. You should get 0.6846. Last one. What is probability of getting at least 3 heads? At least 3 heads. So that will be talking about x greater than or equal to 3. So we are looking for P of 3, P of 4 until P of 8 because we only have 8 trials. Okay, this one you need to think about it. We only learned binom PDF and binom CDF. PDF is talking about exactly at that point. CDF, that will be the cumulative from 0 to that point, to the x. But here, we're starting from P of 3. So what can we do? How can we calculate for this guy? Remember the session 5.1, the probability distribution? One of the requirements talking about when you add up all the probabilities, it has to be equal to 1. Okay, so here, I'm gonna write it out. So P of 0 plus P of 1, P of 2 until P of 8 has to be equal to 1. Okay, we stop at 8 here because the n is gonna be equal to 8. So now we are looking for P of 3, P of 4, P of 5, P of 6, P of 7, and P of 8. This is what we're looking for. I would say P of 3 until P of 8, that will be equal to 1 minus P of 0, P of 1, and P of 2. Okay, look at here. One more time. According to the probability distribution, when I add up all the probability, it has to be equal to 1. And then we are looking for P of 3 until P of 8. So I would say I'm gonna do 1 minus P of 0, P of 1, P of 2 for both sides. You're gonna get this guy. Okay, so let me write it down here. Now, I could calculate the P of 0, P of 1, and then P of 2 using the binom CDF. Okay, so I will have 1 minus binom CDF and P, and then the x is going to be according to here, 2. Use your calculator, 1 minus this guy. You should get 0.9502. Put a star for this kind of the questions. For sure, you guys gonna see it on the exam. Compute the mean and standard deviation of a binomial random variable. For the binomial distribution, we also can find out the mean and the standard deviation. Formula will be here. Mu equal to n times the p. And then standard deviation, that will be n times p times 1 minus p, which is going to be your q in here. And then square root. If you want to find the variance, you just need to take the square of the standard deviation. Example 5. According to the company, approximately 30% of United States households had a digital video recorder, the DVR, at the end of the year 2008. Suppose a simple random sample of 15 households is taken. Use the binomial probability distribution to find the following probabilities. I want you guys try to do it by yourself. Make sure write it all out what you're looking for. P of x equal to what? And then show me your work by non-PDF or by non-CDF. Okay, check your work. First, what is your n equal to? We do have a simple random sample of 15 households, so n equal to 15. And then P, the success rate, that will be 30%, so 0.3. And Q, which is going to be 1 minus P, that will be equal to 0.7. And then we are looking for exactly 5, so x equal to 5. So means P of 5. So exactly 5, so that will be binom PDF. And P and then the x. You should get 0.206. B. Find the probability that fewer than 3 of the households have a DVR. So fewer than 3, that will be x strictly less than 3. Okay, fewer than 3. X less than 3 means you're looking for P of 0, P of 1, and P of 2. So we need to use the binom CDF. Since binom CDF, we could calculate cumulative from 0 to the x, which is going to be a 2 here. You should get 0.127. C. Find the probability that more than one household has a DVR. More than 1 means we are looking for the x strictly greater than 1. So that will be P of 2, P of 3 until P of 15 because n equal to 15. So again, since this guy is not starting from 0, so we're gonna do 1 minus. So that will be 1 minus P of 0 minus P of 1. I put the bracket here, so this guy becomes a plus. And then 1 minus binom CDF until the x here, which is going to be your 1. You should get 0.965. Okay, find the mean using the formula, standard deviation, and variance. This is a variance, and this is going to be standard deviation. So plug it in. The Q, you could plug it in 0.7, or you can use the formula n times p times 1 minus p. Check your work. Okay, mean, variance, and standard deviation. Graph a binomial probability distribution. Scenario, when we flip the bias coin 8 times and then we count the number of heads, we consider the probability of success getting the head is going to be 0.2. So n equal to 8, p equal to 0.2. So now we try to graph it. We're going to calculate it. You could use your calculator to find it out. What is a p of 0 equal to? P of 1, p of 2, p of 3 until p of 8. The picture is going to be looks like this. Okay, so I could show you guys the calculator, how to get this picture. For example, I'm going to calculate p of 0. So I'm going to go second vars binom PDF. We do have an 8 trials. Probability of success is 0.2. X equal to 0. You're gonna see my probability of P of 0 equal to 0.1677. So it's about like here. Do the same thing when X equal to 1. So 8.2, X equal to 1. That will be 0.336. Okay, about like here, 0.336. Okay, so you're gonna do it like one by one until n equal to 8 here. Okay, now we're gonna change the success rate from 0.2 to 0.5. And then we're gonna do the same thing. We're gonna graph it. This time, the graph, it will become the normal distribution. Okay, about normal distribution. And when p equal to 0.2, we do have skew to the right because white tail is longer. Okay, one more. If n equal to 8, and then the success rate is going to be 0.9. So think about it, what would happen? What is your graph looks like? It will be skewed to the left. Okay, because left tail is longer. Okay, so by changing the probability of success, graph the binomial probability distributions is going to be look different. General rules for shapes. If p equal to 0.5, the distribution is symmetric. If p strictly less than 0.5, distribution is going to be skewed to the right. Okay, just like our previous slide, when p equal to 0.2, we do have a skew to the right. When p greater than 0.5, the distributions looks like skew to the left. However, even if the distribution is not symmetric, if we increase the number of trials, it becomes symmetric. The shape of the distributions depends on both n and p. Just like this one, if I want the distributions looks like symmetric, instead of increasing the p, I could increasing the n. Like here, my p is gonna be 0.30, and I increase the number of trials from 8 to 100. So you're gonna see my distribution become symmetric. For a fixed probability of success p, has the number of trials n in a binomial experiment increased, the probability distribution of the random variable x become the bell shape, become the normal distribution. Has a general rule of thumb, if n times p times 1 minus p, this is talking about the variance, greater than or equal to 10, then the probability distribution will be approximately bell shape. That's it.